India's strides in space started right here in Ahmedabad by Dr. Vikram Sarabhai. That was 5 decades ago. Many question why a country like India should get into space. That is well answered now. And if you look at the international scene, India is there in the 6th position for the last 6-7 years. USA, USSR, now Russia, European Space Agency, Japan, China, India. Then comes Canada, Brazil, etc., etc., etc. This has been done qualitatively and quantitatively by organizations in US and Japan, and they continue to do that. But there are areas in which India is number 1. That's in the application of space, for which Dr. Sarabhai said India needs a space program. And now the picture that I am putting here is the one taken by Indian spacecraft MOM after being there in the orbit of Mars from September 24th of 2014. How do we get out of Earth to the space? And when we talk about space, it starts around 100 kilometers above the Earth and to the end of the never-ending universe. How do we get out of it? And the most difficult part of getting there is to get from Earth almost nearly 40 kilometers. And that is done through powerful rockets. We have the PSLV, is very well known. 27 successful flights. Not only it has launched Indian satellites, 71 satellites totally, of which 40 are from foreign countries. And which are these countries? 18 countries, starting from Canada on one side to Australia on the other side. We can talk about France, Germany, UK, all are part of that. Now we talked about the cryogenics. GSLV was tested successfully in January 2014 with India's own cryogenic engine. When we wanted to do this in 1992, there was a problem, international problem. We were not allowed to get this from Russia. But in India, we decided we will develop it. And what is the complexity of developing a cryogenic engine? It is very simple. On one side, there is a combustion taking place, and we have 3000 degrees centigrade. On the other side, we need to have the fluids, the liquid hydrogen, liquid oxygen, to be maintained at minus 253 degrees centigrade, minus 253 degrees centigrade. And there are turbines rotating at nearly 40,000 revolutions per minute. And this hydrogen and oxygen have to come together and start combustion, and we have to sustain. That's simple, the complexity of a cryogenic engine and stage. We did that, and that gave us the capability today to put 2.2 ton or 2,200 kilogram communication satellites from India. Now, we go to French Guiana for launching heavier communication satellites. But with this GSLV Mark III or LVM3 we call it, when it is ready within 2 years' time, we will not go abroad for launching these communication satellites. The global communication market of 4,000 class satellites, which is the state of the art today, would find India as a destination. And what we proved in December 2014, just 20 days ago, was to show that this vehicle in its configuration functions well. It's a crucial atmospheric phase 40 to 120, that range, it works well. And we will be having this capability. This is our state of art, starting from Aryabhatta of 1975 in satellite technology. Different classes of satellites, whether it is for remote sensing, whether it is for communication, or for looking at Mars or Moon. When we made the microwave remote sensing satellite in India, which is shown there in the picture, what we did, this is the second satellite of its kind in the world looking at Earth when there is a cloud. You look at the flooded area, you look at the agricultural crops. That capability India got. And we have also built 2 communication satellites for 2 European customers. And almost 70 such satellites we have made in India, done by Indian industry, done by our own scientists. This is the constellation of Indian satellites operating today. So almost 25 satellites in 2 orbits. One is at 36,000 kilometers above the equator, looking at the communication, looking at the weather. And others are at low Earth, looking at minute objects on the surface of Earth. And I just wanted to add only one more thing. Right from 1995, India has been a leader in remote sensing satellites in the world. And 20 ground stations all around the world were receiving data of Indian satellites from ground stations on commercial basis. And now we have an agreement with NASA to develop jointly a satellite. They will be doing part of the equipment, we will be doing the rest of it. And this is expected to be flown in 2020 from India using our own launch vehicle. This is the set of applications. The very fact that Honorable Minister talked about how it is being used for looking at biodiversity, how it is being used for understanding the movement of a cloud system and the cyclonic system, that shows how this has been imbibed into the working of various ministries, departments. And only in India you can see 60 central ministries and departments looking at remote sensing or communication to be part of their governance process, development planning process. And if you want to see how in a state remote sensing is being used, just go to the Gujarat State Remote Sensing Center. There are nearly 1,200 persons working in this area. Or kindly ask our Honorable Prime Minister, when he was the Chief Minister, how beautifully he used the space as a tool for governance and development in this state. You could see him talking to a set of students, and this is the tele-education that was made possible through this satellite medium. And finally, the Mars orbiter mission. In 2008, we went to Moon. We had an orbiter around Moon, Chandrayaan. But then we decided to go to Mars in 2013. Just a couple of things only I wanted to say. Time is the essence because there are specific slots in which we can go. 2013 was such an opportunity. We decided we are going to do it. And then we used our PSLV, and in a novel way, we reached a place from where we started our journey to Mars. A vehicle which had only 1/10 of the capacity of what was used by US recently for the MAVEN mission. And we did it in 4.5 years from concept to fruition. What are those critical things? One is distance. We are talking about nearly 55 million kilometers when it is closest and 400 million kilometers when it is farthest. But you don't go in a straight line from Earth to Mars, you go through a heliocentric, an arc around Sun. And the distance to be traveled is 660 million kilometers in 300 days. And a signal to reach the spacecraft would take about 10 to 15 minutes and back to. So we had to build a spacecraft with autonomy that it takes its own decision. We also had to use the PSLV in a very novel way to get those conditions that were required. We needed to have deep space communication. But more than that, this is a mission in which we respected the mathematicians. Because when it started its movement from Earth orbit to Mars orbit, we had to put it in such a direction that on arrival, the distance from Mars will be 500 kilometers after a travel of 660 million kilometers. What are the influences of other planets on the spacecraft, of Sun on the spacecraft? All had to be computed well in advance. What would happen after 300 days needed to be known on December 1st. We did that, and that's why we could reach. And finally, how do we reduce the velocity and do that insertion, which was a tricky affair, which we did. And if we did not do that on that day, on September 24th morning, we would have lost this mission. But a lot of learning took place. And finally, these are the kinds of pictures that we are getting. There are 5 instruments which are making a lot of measurements. This is possible because the collective wisdom of the people who worked behind it. Nearly 4,500 young minds are working on this area, and nearly 16,000 people in ISRO from all parts of the country. So for the young people I'm talking about, this is one place where you would find kind of kick that you get when you do the work. And we started a Facebook just to say 800,000 likes, now it is close to 900,000. And they discuss mathematics and physics. And people say, why did I study hyperbola or parabola in my younger days? I find a relevance for it today. And that is one of the intangible outcome of this mission to this whole country. So this is something which we should be looking for. India has the capability, Indians have the capability. And lastly, in the 18th century, one of our poets from South India wrote, Angaragamashrayamyaham Vinada Shridajana Mandaram Mangalavaram Bhumi Kumaram Varam Varam, about Mars. Bhumi Kumaram he wrote in 18th century. And we say he is our nearest neighbor. There are a lot of commonalities or comparative things between Moon, between Mars and Earth. And we are looking at habitat maybe after a few decades or centuries in Mars. So this is the future. We will be talking maybe such a pravasi from Earth to Mars. Thank you.